IPsec site-to-site
Yes.
VPN
Yes. Correct.
policy mesh. Okay. Is there anyone who is working in service provider network, like on the core MPLS, L3 MPLS, L2 MPLS, like that? Is there anyone?
Yes, I am working.
Okay.
I used to do BGP provisions
In the
and
service
VP
provider
stuff.
network.
Yeah,
Okay. So you are
and little
managing
bit of some
P2P,
OSPF. Yeah,
P2P.
yeah, creating BGPs between yes, different ways.
Wow. Great. Definitely will design your network, company network in the event.
Yeah,
We'll see there how it's working. By the way, I have some lab. Okay, let me show you. I have created, I think, 3 to 4 lab for the basic to advanced. Is there anyone else who is working in service provider network? Otherwise, I am going to show you some lab. If you guys will agree, then I will include that. Otherwise, if anyone have the scenario, real-time scenario, actually I have created lab based on my past experience. Now, if you have something else, you can let me know. Like in the OSPF, you want to include this scenario where you are using in your company, right? Maybe someone is using BGP, OSPF together. They have issue in redistribution like that, right? But first, I will show you my topology. But I don't have topology for all the protocols. I have topology now for OSPF in the internal network. We can have 2 sites hardly, till 2 to 3 sites. I have topology. I'm going to show you that. Yes, anyone else want to share anything, guys? Here. First of all, thank you
Hi,
so
sir.
much. Yeah.
Yeah,
Oh,
hi, this is Ranjit. Basically, I've
yes.
been listening to your videos on YouTube, and this is the first time I'm joining the call. See, my company, I mean, where I'm currently working is in branch locations they are using BGP, and in DC we are using OSPF, and I'm not having any good hands-on on the like we have router redistribution related work recently, but I couldn't get that.
And
So with
exactly,
this
I was
training,
looking for, this type of people only, like you.
yes, sir. So
Great.
hope I mean we will get to see our scenario also. I'll try to give you my current scenario where I'm looking for more help.
Yes,
Maybe we'll see if we can build that in lab. And also more into VRF side. When we are internet router, also we are using VRF,
correct.
where we would like to have one is for proxy side and one is plain internet for the server side. So we will. I mean, I'm requesting these kind of scenarios
Yeah,
going forward.
we'll try to include maximum. Like, um, if you all are going to share your scenario, like where you are working, right? That will be sufficient, I think. That is going to be sufficient lab. And I have already few labs.
Sure.
Yes.
So Prabhul, so after this training, like you can assure us, like if we sit into any interview for like OSPF interview asking OSPF, BGP will be able to answer, right?
It's my 100% guarantee, 100%.
That would be great.
I
Yeah,
know
thank you.
you guys are thinking like that, but see, in any interview, even in the Cisco, Juniper, Aruba, Google, Amazon, doesn't matter where you are applying. If they are going to ask you question from the OSPF, BGP, MP-BGP, VPN, or MPLS, right? Doesn't matter which question, you will have answer of each and every question just after this training program. 100%.
Thank you, Prabhul.
Yes, thank you, sir. Yeah, that's what my problem is. I keep failing interviews. I have failed all 100% interviews in last 2 years, and I've been unemployed for last 2 years.
Oh my God. So sorry.
Yes, so I mean, I have good theoretical knowledge, but when it comes to like hands-on and
Exactly.
uh,
You need hands-on only. That's very
yeah,
important for you.
yeah. So I have developed a huge fear for appearing in interviews, and I don't even attend any interviews. That's how much
After this
have
training,
been
try
actually
to
suffering.
practice
Yeah.
with me for mock interview.
Okay, yeah, sure. I would love to do that. So if you're available to help me
So at the
with
last,
mock
we'll arrange
interviews.
some mock interview session as well from these topics only.
Yeah, that would be awesome. And how do I don't have my name here appearing, so how do I edit and
See,
enter
while
my name
joining, you should rename your name, right? I will
before
request
joining?
everyone to come with right name. So your name here, it's not showing. It's saying name not available.
Yes, I don't know. Maybe I have to log out and come back in again.
Tomorrow you
So
can try. No
yeah.
problem.
So let's just move forward without name, and I'll
Yeah, every day
do
in the
something
beginning,
about it.
first of all, we are going to talk for some time, like to revise the previous class. Okay, then only
Yes.
we'll proceed.
Thank you, sir.
And I also don't know the duration. Minimum duration is going to be 1 month, but it can take 2 months as well, guys. Honestly, I'm saying here, I also don't know the syllabus, and until I will not cover this, I'm not going to take any other class. So I want to involve myself fully here.
Thank you, sir.
Okay. So just one thing I'm expecting from you, that you will also configure the lab with me.
Sure.
You have to promise that, but that's it.
Sure, we'll do it.
2 hours here, 8 to 10, and maybe 1 to 2 hours for lab configuration, right? And anytime you can configure it. Configure it, save the configuration, and if possible, then share the lab with me. Later, what we will do, we will have some lab where first you will perform the configuration, you will share with me, and after that I will create some problem there. After that, again I will send you to fix it. Or you can access my lab as well remotely. If you will have any lab and anything which I need to share, then I will share my lab access as well. No worry. But I am expecting everyone have the GNS3 and EVNG, at least GNS3 or EVNG. Any one software is fine.
I have PNet lab. Is there any issue?
PNet lab is also fine. No issue.
Thank you.
So these two softwares, guys, GNS3 and EVNG, anyone. The next software which is required is Secure CRT. You should have Secure CRT in your laptop. Secure CRT to capture some time link, right, to see the traffic. Maybe let's say for an example MPLS header, right? So how we'll see what are the information inside the MPLS header. For that we'll capture the link to check any data. And Secure CRT is one sniper tool. Okay, clear?
Secure CRT or Wireshark?
Sorry, Wireshark, not secure.
Yeah.
Secure Wireshark. Yes. Anything else? Anyone? Otherwise, I will share my screen and will show you the lab, some lab which I have created here.
Yes, you can, sir.
Let me check. 28 people are there, and most of you are working professional. I think 2 to 3 are only taking rest. Even they have experience. We all are experienced one. Okay, and guys, don't worry about the syllabus and those all things. At the last, you can match the syllabus of OSPF, right? For now, for next few classes, forget about the syllabus and those all things. This is like a story. Let me see here my screen. Is my screen visible?
Yes, I can.
Yes.
You can see. Okay, great. Let me access my EVNG lab 192.168. And here I have one new batch, something like, yes, here it is. So I want this lab. This is just one branch of any company. Is it fine? I'm expecting you all are familiar with this type of network. This is only one site, one branch, one small site. You can say, you can also say the data center, headquarter, right? You can say the campus. This is one site. See the topology, guys. Is there anything which is not clear to you? Why we have connected that device there like that? Yes, Rajat.
If you can explain real quick, that would be helpful.
Yeah, we'll explain. You tell me now, here in this lab, guys, tell me where OSPF is required. In this lab, see, this is my, let's say, DC, data center. In the data center, some servers, lots of servers, or side one, any side are there. All these are end devices like access point, host, server, FTP server, Linux machine, users. They all are connected to access layer switch, access layer switch, access layer switch, layer 2 switch. All the layer 2 switch is connected to distribution layer switch for the policies. Here, my distribution layer, this is going to be gateway. Here we'll apply all the policies in the network, whatever policies are there. And after that, here I have WAN edge devices where we'll configure the NAT, VPN, right? Cloud access. Here you can see maybe this company have some application on cloud, right? So cloud is reachable from this section. Internet is reachable from this section, right? So actually this layer is connecting WAN to LAN, which is core layer. Core layer in my network. Distribution layer of my network, right? And my core layer is connecting LAN to WAN. It is also connecting server room, right? Maybe different building or different floor. Network services, maybe I have a small domain where I placed one ICE server, ACS server, WLC, some controllers are there. Or suppose SD-WAN controllers are there, vManage, vSmart, vBond. These controllers are there in this domain, right? So company has a simple requirement. Some end devices means servers, some controllers are there at one side, right? Some web server, let's say, are there. And after that, we have another site and some application on the cloud. That is the requirement of company. Company requirement is they have some servers, some end devices, some servers which is maybe reachable from internet, web server, some controllers are there, cloud connectivity and internet connectivity are there.
So, sir, network services, we keep it separate from the LAN?
No,
network?
In the LAN only it is. You can create it like this also. Let's say access layer switch, and here I can place user as well as server, as well as my ICE server, these network services. Here only I can place WLC, I can place the access point server, and then I can connect to one router and router to internet. This is also possible.
So why is it connected to L3 switch, Praful? Is there any reason for that, or?
Yeah, see, what is the reason of this topology? Let me tell you. See, for an example, if I will talk about a simple, small company network, right? Where we have, let's say, 500 users, some servers are there. I am going to connect all end devices to switch. Again, you can ask me that, Praful, on single switch. By the way, switching is not our syllabus, but let me tell you at least the basic connectivity. Done. If you are going to think, Praful, here I have lots of devices, 500 devices on single switch, how I will get 500 ports? So actually you are going to stack the switch. You will use switches in stack here. We will have a stack wise switch. A stack wise switch means multiple physical switches are combined into single logical switch, and on that single logical switch you have lots of ports multiplied by multiple switch, right? and I can connect it to router and router to internet. This is fine. These users can access internet. Yes, can access internet. These users can communicate with each other. Yes, they can communicate with each other. If I have any another site somewhere, there also I have same setup. User connected to internet means LAN and WAN. LAN WAN, you know na? What is LAN? What is WAN? LAN is local area network. My private network. Local area network means the network implemented in a small geographical area. Guys, always keep in mind, we divide network on the basis of area, not on the basis of user. We cannot say how many user can be there in LAN or how many user can be there in WAN. This is incorrect question. We divide network on the basis of area. So if my network is limited to a small area, that is going to be considered as LAN. And if it is covering large geographical area, that will be considered as WAN. Right? So my network is very small, internet is very big, right? That is WAN, and my network is LAN. LAN WAN, both side. WAN means public network, LAN means private network. This is public and this is your private. This is public, this is your private, right? And by default, private and public cannot communicate, because guys, here the IP address is which you will configure is private IP, and here public. So private IP and public IP cannot communicate. ISP router will not have route of private subnet. It will discard the traffic. Yes, Rajat. You don't need to raise hand. You can speak directly. If you are not speaking, then keep yourself on mute. If you need to speak, just unmute yourself and speak. Yes. Any question? Rajat?
Yeah, probably one question. In earlier diagram, in your topology, can we also include firewall? If firewall,
Yeah, I am coming
include
there only. Yeah, definitely we can. Why not? See, the reason why I have not installed any firewall is connectivity. My main purpose of this course is connectivity, covering mainly these protocol first, not the security fundamental, right? But you can add it. If you will ask me, then later I will add the firewall also. Like that, we will have multiple topology. We have so many topology. I'm going to show you all. Don't worry. See, I'm coming to that topology only. What I'm saying, LAN and WAN cannot communicate by default, because here private IP, here public IP. And the technology which we are using to make it possible means LAN to WAN communication or private to public communication is NAT. So here you will configure what? NAT. And two private site cannot communicate over public. Again, because here public subnet, here private. Private and public again cannot communicate. And two private site over public cannot communicate by default. Even by configuring NAT also, by NAT, what will happen? Your users can access internet, that's it. You cannot ping to private IP address, any remote site private IP address.
We need to use IPsec for this scenario.
The technology which we are using to make private to private communication over public is VPN. Here we have to configure what? VPN. So on the same router we'll configure VPN as well. VPN is not secure, so you can configure IPsec. IPsec VPN. IPsec is also one type of VPN. Forget about types of VPN. VPN means virtual private network. That's it. Which is used to make communication possible between two private network over public network. Technology used to make communication possible between two private network over public network. Always keep in mind, by default, two private site over internet cannot communicate. Right? Side A.
Excuse me, I have this question.
Yeah.
So from this diagram now, the two routers are connected via VPN, right? So is it gonna be the company router or the one that the ISP provided?
No, this is your router. This is configuration of NAT VPN is your responsibility.
VPN on our own router. Okay, thank
Yeah.
you, sir.
Even here on the router, you will configure default route towards ISP to route all the traffic towards internet, like 8.8.8 or any public IP address. One default route, NAT, VPN. So actually, what is the purpose of this router? I don't want to discuss VPN here, guys, really. Not even NAT. Just I want to tell you one thing, that what is the issue in this design? What is the issue over here? Is it good network or not for the enterprise company? Definitely answer is no. Then why? See, the main responsibility of this device is NAT, VPN, later maybe IPsec, and many other WAN technology. At the same time, this is router. Remember, router is used for routing. Used for routing. Now guys, LAN side, what I am assuming that here I have 5 department, right? Department A, department B, department C, department D, or 1, 2, 3, 4, 5. 5 departments are there. And we have separated department with the help of VLAN here. We have some VLAN through which we have separated it. Done. So this router is only going to handle inter-VLAN routing. Am I right? This router is only going to manage inter-VLAN routing, right? Here only you will create the SVI for VLAN 10, 20, 30, 40, like that. So same router is performing LAN routing as well, right? Your router WAN is device is performing LAN routing, means inter-VLAN routing, WAN routing, NATing, VPN. Definitely load over here on the single router is going to increase if we'll increase the number of user here, or if my traffic is going to increase. If my traffic is going to increase, this router can not load these all things. Device will start using 100% CPU, and also device will reach to 90% CPU. Even you will start getting bad performance, low performance, right? Sometimes your router can get hang. See guys, now remember this is network, right? Here for an example, these are the bank employees. So many people are there in the queue for the transaction, and their server is not available, right? So internet should be available 24/7 in the companies, bank, enterprises, right? Everywhere, by the way. Even I am teaching online people, I need 24/7 internet. I have only 2 work online, but both are work online. My office work and teaching, that's it. My office work and teaching, and I need 24/7 internet. Even I cannot survive 10 minutes without internet, right? So think about the company. If the router is going to hang, or guys, if any link flapping will be there here on this WAN link, any small link flapping can break the entire neighborship. Maybe you have VPN, and over VPN you are running, let's say, OSPF protocol. So if this WAN link will flap, a small flap, OSPF neighborship will goes down. If your OSPF neighborship is going to down, again both routers are going to form OSPF relationship by encapsulating lots of messages like hello message, LSAs. CPU utilization will increase every time whenever the link is going to fluctuate. Or if I will have, guys, hardware failure, then definitely I will lose the connectivity. If this link will goes down or switch will goes down, no, there is issue, right? So that's why I have connected multiple switches here. I will take you to my design now. See here, what is happening here at access layer, guys. You can see, for an example, this is a stack switch 1, a stack switch 2, a stack switch 3. Here I have users, here users, some server, and all the servers are there. All are connected through access layer. And now first I have connected all the access layer switch to distribution layer switch. Why? Let me tell you. See, if I will talk about the traffic of this user, so this user is going to generate internet traffic as well, right? For internet, user will access internet. So switch is going to receive internet traffic. Switch is going to receive traffic for server room also, yes. For the network controller services also, yes. If you are running any service on cloud, yes, it is receiving cloud. data as well, right? And even this is very a small setup. So a stint of forwarding all the traffic through a single distribution layer switch. I have installed two distribution layer switch to enhance the performance. Why? Now I will load balance the traffic. Right? Let's say this device is good, better than switch 2. So I will forward all main traffic, the mission critical traffic through switch 1, and all the general traffic towards switch 2 through switch 2. This way we can distribute the load. We can reduce the load. Guys, see, I am not involving the router even to reducing this load. I am just adding two devices here. Router is, I am going to show you, router is responsible for WAN mainly. Right? So first of all, here we have two distribution layer switch to distribute the traffic which is going from here to maybe internet or to WAN to network service or to server room, right? We can send some traffic towards switch 1, some traffic towards switch 2. In this case, if I have single switch here and switch will goes down, guys, or any link will goes down, you will lose the connectivity, right? So it is also providing the redundancy. If any switch will goes down, let's say switch 2 will goes down, automatically switch 1 will start forwarding all traffic. Again, when switch 2 will come up, it will start performing load balancing, distributing the traffic. That is not load balancing, we can say load saving. Second benefit of distribution layer is, guys, this is what? This is the function of distribution. It is clear with your name, distributing the traffic. Distribution means traffic distribution, right? It is collecting traffic from multiple access layer switches and distributing them, and after that forwarding to upper layer. Right here I can have one more switches.
Sir,
Yes,
the inter-VLAN routing will be performed at the distribution
yes,
layer?
definitely.
Okay.
Yeah, so sir, the distribution layer from this topology now, is it a stack-wise switch, right?
These are a stack-wise switch.
What about the distribution switch?
Distribution switches are not in a stack.
Okay.
These are
And,
layer 3 switch. The difference between this switch and this switch is these are L2 switch, works at layer 2, means it forward traffic based on MAC address, and this is L2 plus L3. It is
Like multi-layer.
also performing MAC
Yeah.
based forwarding and IP based forwarding, both. And your
So
router,
the cable,
yeah,
from the cable management now, I'm just looking at the scenario whereby the two distribution layer switch, are they in the same server room, and how the cable management is being done? Is it just connecting them using fiber, or just
no, I am assuming these all are in same campus. Yes, maybe they are fiber
Yes.
cable. Let's say distance between the server room and my DC is 500 meter, and here we have fiber cable, definitely.
Okay, so the server room won't be treated as a WAN. It will still be treated as a LAN alongside with the
Yes, you can
internet
say
network.
LAN
Okay.
1, LAN 2, like that also.
Okay. What about the cloud? Is it also going to be treated as a
Cloud means,
probably you are synchronizing Azure to your network?
yes,
Is it going
exactly.
to be treated as a WAN, or is it going to be treated as a LAN?
No.
You know, this is the
Cloud is
internet
WAN.
side.
Cloud is WAN. This
Okay.
one is WAN. This one is WAN. These two are public network. This is the way. This what I want to show you here, that this is the way to reach cloud. Cloud means, let's say the company has some application, app 1, app 2. App 1 is running over here in my data center on premises, and app 2 is my critical application. That's why I'm running it on cloud, right? So this is the way to go cloud, to reach that server. The main purpose of network is connecting servers and employees, clients, host.
Yes, sir, I get it. So the in another scenario, the server room and the network services can also be connected
See,
to the
brother,
distribution layer, right?
let me tell you one thing. You can place this network services in different side also. No problem. At different side. In my case, it is in LAN. This you can place it here and this here. like this, right? But you can place it on WAN also, on service provider, and then through service provider you can have access. This is way to go controllers. This is way to go server room. This is way to go cloud, or WAN means to other site, right? Maybe I have another site somewhere, so that is connected through this WAN. For the internet, this. And see, for all the we have router here, right? The mainly router is used for routing, means for the selection of best path, right? Guys, path is already here, right? Let's say here I will talk about one city, Jaipur and Delhi. Between Jaipur and Delhi, guys, so many roads are there, right? You can consider this road as your link, your fiber cable, which is connecting multiple city. Where is the need of router? Where is the need of router here? These are the link, which is your road. You know, on the road, traffic police are there. Traffic police who is controlling the traffic, right? Whoever is going from Jaipur to Delhi, right? He is going to control that. Okay, your car go left, your truck go right, like that. Router is for making decision of routing, where to forward the traffic, right? So these are the different way to go in this section. I have two router in my network. Via router number 1 also I can reach to these services. Via router number 2 also I can reach to these all services. These are my critical part of network, right? So I will take you over here on the core layer. First of all, let me finish the distribution layer. What I told you, the first function of distribution layer is distributing the traffic. It is receiving traffic from multiple access layer switches and it is distributing it. After that, it will forward to core layer, upper layer, and core layer is responsible for, guys, WAN connectivity. Now this distribution layer is also going to take responsibility of gateway. Gateway means gateway of these user. Here you can create SVI. You will create SVI, right? Let's say you have 10 and 20, so you will have 2 SVI over here on this switch, on both switches, right? Generally here we will have active or passive scenario, HSRP or VRRP, GLVP here for the load balancing, or maybe for the redundancy, and so many SVI for the gateway. Now on distribution layer switch only, you can configure the policy as well, right? Let's say sales department is there and HR department is there. What I want, sales department user should not able to access a particular application of this server, right? That can be one policy. Some sales user should not be able to access one application in the HR department. So we can apply those types of policies over here also, because now distribution layer is switches, guys, forwarding traffic based on IP. It is behaving like layer 3 device as well.
Any which ways, they are part of different VLAN, so they won't be able to receive it. Why do we need policies?
No, if you are not going to configure inter-VLAN routing, then entire communication is going to be blocked. See, through SVI, we are just making inter-VLAN routing. By default, VLAN 1020 cannot communicate. That's why I have created SVI here. Na? If you will not create the SVI, then entire communication will block. Your question is good and it is logical, that if we have divided the network through VLAN, right, to stop the communication, then why we are configuring the policy? So no, first we have divide the broadcast domain into multiple parts. Large broadcast domain into a smaller broadcast domain, and after that we are making reachability. What is the benefit of dividing large broadcast domain into a smaller domain? Guys, assume if these all switches are in single broadcast domain, then what will happen if any device will generate broadcast message? Let's say this PC is going to access internet. To internet access, default gateway is required. It is going to generate ARP request for their default gateway to resolve MAC address. ARP is a broadcast message. Whenever PC need to send traffic to different network, it will generate ARP for their gateway to find the MAC address. And ARP is broadcast. Broadcast will reach to switch. Switch will forward to this switch. Switch will, and also to this switch, this switch. This switch will also forward to this switch, and this switch will also to this switch, like this broadcast message will be flooding here, right? And all these devices, right, let's say I have 500 users, so all the 500 users are going to receive the broadcast message. It will check the information at layer 2, it will check layer 2 MAC address, destination MAC address is broadcast. Oh, it can be for me also. Guys, devices accept traffic in two cases: if destination is their IP address or MAC address, or it is broadcast. That's it. If destination is anything else, then your device is going to discard it. But it is broadcast, it can be for server also, right? So it is going to check upper layer information, and then it will say, okay, target IP address is default gateway IP address, it's not for me, it will discard it. So every time whenever anyone will generate ARP message or any broadcast message, or in case of MAC flapping, broadcast flooding, every time what will happen? All your LAN devices will use CPU, and there will be unnecessary traffic on the link. That's why you have divided into multiple parts with the help of VLAN. Now, if we have separated the department, that means we have separated the broadcast domain, right? Now, if this user is going to generate broadcast message, that will flood in this area only, in this domain only. But guys, department should communicate. Both departments are part of my company only. Sales and HR should communicate. So here you will create SVI. Now they can communicate. And after that, you will configure all the policies. You will have various policies. You can apply all the policies over here. That is the main function of layer 3 switch. Difference between layer 3 switch and router is, guys, router is designed for core routing. Core routing means LAN and WAN routing. And L3 switch is designed for inter-VLAN routing, not WAN routing. Which routing? Inter-VLAN routing, IVR. It is for LAN routing, not for WAN routing. If you are thinking that, Praful, just replace this router by this switch. No, bro. This is not designed for WAN. This is designed for LAN. Here we have some core switch which support WAN technologies, but not all the multi-layer switch. This device is designed for inter-VLAN routing and means to manage all the LAN traffic. In the previous diagram, my router was only managing everything, right? The department, inter-VLAN routing, separating the department into VLAN, LAN, WAN, right? Now we have separated layer here, right? Guys, the benefit of designing network by following this architecture is scalability. Scalability means very easily you can increase the size of your network. If let's say tomorrow 10 more employees is going to join the company, no worry, this network can handle it. But your previous network like this, no.
Sir, just for understanding purpose, so the layer 3 switches, they are not WAN routing capable?
No, few devices, few layer 3 multi-layer switches are WAN capable. They are specifically designed for WAN, not all multi-layer switch. Here I am using the multi-layer switch which is not supporting the WAN.
Okay, sir.
Right? Even you can enable the NAT, then also it's not recommendation, right? You will not get better performance because it is not mainly designed for NATing. Maybe in the small organization, if we have some requirement, then we can configure it. No problem. Yes, go ahead.
Yeah, so from my own experience, I work as a one NOC engineer, but the core, why I'm confused right now is that the distribution layer we use, we don't use, I don't think we use a core router, we use a collapse core. So the distribution layer, we use 9500 catalyst, and it's been stacked together. So after that, we are connecting with a checkpoint.
That
so
is
the
also
core
one
layer
design like this.
Oh, okay. So
Brother,
it depends on the requirement of the organization, right?
Yeah. So what you can do in your EVNG or GNS3, you can design that lab. You can share with me. We'll see the configuration there also. This is one very simple design. Just see, some people are not able to even understand the SVI properly. They are saying why we are configuring the policy, right? So I am taking from the simple. This is so simple lab, right? Here at distribution layer, who told you that you cannot configure the stack? You can.
So why we are going for L2 and L3 capable in distribution? We can use L2 only, right? Like since we are performing L2
Then
tasks,
who will perform routing?
we have core routers, right, for routing.
Yes.
For distribution layer, instead of L3, L2 capable, we can use only L2 switches, right?
L2 switch then router, na?
Yes.
Yeah, you can.
I mean, no. Instead of distribution layer switches, we can use normal L2 switch.
No, then you cannot create SVI. Then what is
Why?
the benefit of applying connecting L2 switch there?
No, even in L2 we can use .1 queue, right?
No. Dot one Q means on L2 you can configure the trunk link.
Yeah.
L2 switch cannot perform layer 3 forwarding, na? It cannot understand IP.
Mm-hmm. Okay.
L2 switch works at layer 2 means what?
MAC
Guys,
address
if I
only.
am saying router works at layer 3, what is the meaning of this? It means router forward traffic based on layer 3 address, means IP address. Layer 2 switch means forwarding traffic based on MAC address, layer
MAC
2
address.
address.
In that case, layer 2 switches will not do the inter VLAN routing.
Yes.
And then it will be performed by the router. So router will take the load.
Okay. Yeah.
Yeah. Okay.
Right? Scalability, guys, stability, redundancy, availability, you can see. I have redundancy at each point, right? So if any ISP is going to go down, or maybe any device at core layer, no problem. Any device at distribution layer, no problem, I have redundancy. It is not going to happen like all the devices will go down at the same time, right? You need at least one backup path for each point. At each point you should have backup. And backup means, again I am not saying that my switch 2 is going to be idle or this router is going to be idle. It will be distributing the traffic, means load balancing plus redundancy. That is the benefit of using multiple distribution layer switch here too. Availability, right? Major task of distribution layer is combining the traffic from the access layer, collect the traffic from access layer and distribute it to upper layer. After that, when traffic from internet or server network service, means controllers or the cloud will come, again distribution layer will do what? Will receive the traffic from core layer and it will distribute it into multiple access layer switches.
So basically, to reduce the load of the core router. Sorry. Yeah, please go ahead.
Thank you. Sir, you talked about defining a policy at the distribution layer. Are you talking about ACLs?
Yes, ACL, VLAN ACL, private VLAN.
Okay, sir. Thank you.
So many things are there.
So the distribution layer is the only purpose is to reduce the load of the core routers, right?
Policy, applying the policy for LAN. If you are going to configure the policy, maybe you will have limitation, right? In the LAN network, definitely we need distribution layer for policy. Policy, redundancy, scalability, easily you can add more devices, you can increase the size of network. If in future I am going to connect one more server room over here, no problem, I have two distribution layer, just I need to connect here, that's it. Devices for new site, means servers, one switch there and few cables are required, that's it. And my network is capable to handle all the traffic, right? If later, see, if you have, again guys, huge traffic, maybe you need to add one more device over here, one more device over here. After that, between the router and WAN, you know, here also we can have some devices, like we can have firewall. Generally here also we can have firewall and here also we can have firewall, or we can have one centralized firewall also here, or I can place it here as well, no problem. Firewall. Anywhere I can have one firewall for protecting the network from attack. Not for policy. Not for policy, guys. If you want to configure, let's say, limited access to the internet, like your requirement is sales department should have limited access, should be only able to open the google.com, should not be allowed to access Insta, Facebook, and those all things, right? This is one policy. Router can also manage it, because you have already reduced the load on router, no, right? You have memory, free memory here. You can utilize in these all things. Guys, here, where is the need of OSPF then? Everything is fine. Then why we are starting from the OSPF? Praful, where is OSPF? So guys, what I told you,
So distribution and core, are we running OSPF between them?
what I told you here, we have SVI for VLAN. Let's say VLAN 10 is one SVI, means connected network on distribution switch 1. Here you have some connected network, all the VLAN connected network, connected to VLAN 10, connected to 20, connected to VLAN 30, 40, 40, 50, like that. Here also. On all these SVI, we will have interface. These interfaces will be in Ether channel, in L3 Ether channel, right? Again, this can be L2 also. If you are going to say it will be L3 only, no, it can be L2 also. If you want routing here between distribution switch 1 and switch 2, to make more effective your network, you can configure L3 Ether channel here, and over L3 Ether channel also you can run protocol to exchange the routes. Means we are making L3 reachability between switch 1 and switch 2 by using this switch port, right? So okay, here we have, for an example, L3 Ether channel, we have SBI. These interfaces are going to be L3 interface. So here you will configure one subnet here, 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 here. Now, guys, these SVIs should be reachable from your core devices. Yes, core devices. Guys, how my routers are going to route the traffic towards internet? First of all, see if this user want to access internet, or you can assume want to send data in server room or when cloud, it will look up for their gateway. Their gateway is going to be, let's say here we have SVI for VLAN 10. It will forward to their gateway. Their gateway will compare destination IP with routing table. This is the behavior of L3 forwarding. L3 forwarding means compare the destination with routing table, right? Let's say in destination IP is 8.8.8.8. Switch is going to say, okay, destination IP is 8.8.8. Let me compare it with my routing table. It will open the routing table. It will find the route. What I told you, L3 devices means router are used to route the traffic, to find the best path, right? So maybe it is forwarding traffic to router number 1, or as it is public network, we will have one default route here, one default route. If it is forwarding traffic to, let's say, this server whose IP address is 10.1.1.1, right? So router, this switch will have this time route towards R1, and again R1 will compare destination with routing table, and this time it will route the traffic towards this server. For the internet, we will configure one default route on my edge router 0.0.0, and we need this default route on all LAN devices, all the LAN devices. And what I told you, router 1 also need this network, right? When this user is going to generate traffic for the server, it will forward to gateway, gateway will forward to router, and router should have route. So this network is directly connected, it will forward. But when server will generate reply for this network, destination will be from this network 10.1.1.1, right? So router should have route towards this switch. So for route exchange, here we will configure what? OSPF protocol. OSPF. And in the same OSPF, we can redistribute default route. So all the LAN devices will get default route. And now my switch can route the traffic to router for internet as well. So routing is required to share internal route first of all. Forget about the WAN. First here we have some connected network. We need to send that to router number 1. Can I configure a static route here, guys? Tell me. Can I configure a static routing?
Yes.
Bro.
Yes, but that would be for you have to configure separate routes for each network.
See, we have
It will
multiple
be very
paths. We have
cumbersome.
redundancy. In this case, we cannot configure a static route. Disadvantage of a static route is if you have multiple paths, then you can't.
You
R1, R2, R3, R4, R4. Here LAN, here LAN. In this way, we cannot configure a static NAT. Because if let's say LAN 2, for LAN 2, my next hop is router 2 on R1. And if this link will goes down manually, I have to change the static route. So whenever you have redundancy, you will configure the dynamic routing protocol. And in the production, most of the time we are using OSPF here only. So we'll configure OSPF protocol here to advertise all connected network from distribution layer to router. After that, this here we will have one subnet, here we will have one subnet. This subnet should be also installed in the routing table of your distribution layer switch, then only it can route the traffic towards server. So through OSPF only will, maybe here also we are running OSPF. Through OSPF we are advertising if we have L3 device here. If we have L2 device, then on the router maybe it is connected. Definitely this will be L3 device. Here we can have SPI and here we are running OSPF. Again here we are running OSPF. And through OSPF, we are advertising this subnet to core router, this subnet to core router, and then core router is advertising to lower switch. So if I am going to enable OSPF routing protocol, my all department can communicate. For remote side, also here we can have route through any another protocol, let's say BGP. Through BGP I am receiving route of remote side. Here we have default route, we are redistributing that in OSPF, right? So all my L3 devices will get automatically. All will get to know that R1 is the gateway of last resort. So here we need OSPF for routing. For LAN routing. After that, guys, see, if I will talk about this section, WAN, like let's say two sides are there. This is DC and I have one side one also. Then how will connect that? Through internet also we can connect. Right, here I have internet connection. Here I will have public IP address. Here also I will have public IP address. I have somewhere remote side. There also if I am going to connect it to internet, I will get one public IP, and this public IP address will be reachable because both the ISP are connected to internet, right? Public IP addresses are reachable. So with the help of public to public, I can create VPN here. What we can create? VPN. Let me show you that lab. New design. Yeah, like this you can see. Like this, if I have two sides, now assume, see, I have made the design so simple here. Because now you know the internal design, how it is going to be look like. Right? VLAN 10, 20, 30. Here we'll create the SVI on single switch. Here we'll configure the routing protocol OSPF to advertise LAN prefix to router. And towards internet, we will have default route. Right? Here also we will have default route towards internet and OSPF routing protocol internal. Through OSPF, you will be redistributing default route, right? Means you will advertise default route to LAN switches through OSPF protocol. Default route means 0.0.0.0. Here also 0.0.0.0. Right? NAT, and after that, after NAT, this side, these user can also access internet, these user can also access internet. But can these two sides communicate? No, these two sides cannot communicate because of private public, right? So here you have one public IP, here you have one public IP, and these two public IP addresses are reachable. So with the help of these two public, you will create virtual private network, right? Means, see, virtually I am connecting my two sides. Now it is similar like the LAN. Like you can assume that there is direct link between router 1 and router 2. Direct link. How this link is up? With the help of public IP address. Who is responsible for public reachability? Internet. You are paying to the internet for same. Right? And now guys, here on my interface of virtual network, I can configure one IP, let's say 10.1. Not 10, let's say anything. Tell me 172.16.1.1, let's say here, and 16.2 over here. Both private IP address can ping each other. And here also you can now enable what? OSPF. OSPF is already running between router and this switch. Now OSPF is running between router 1 and router 2 also. Our tunnel, our VPN, and OSPF is running over here also, right? So tell me, these all can exchange the routes or not? Side 1, side 2, yes. They all can communicate. Again we have same topology, but now what we did here, we have created the virtual network, and then I have enabled the OSPF protocol. OSPF is already running here, and OSPF is already running over here, right?
But I have one doubt. When you created this VPN OSPF, this from R1 to distribution OSPF, this will be redistributed in that VPN.
No, if we are running same
OSPF?
protocol, why we need to redistribute? Not required. Okay, but guys, internet is, right, it's not 100% reliable. No one is going to promise you the uptime, right? There is no any SLA for uptime if you are connecting to private site through internet. So what we need? More reliable transport to connect two sites. Good thing with internet is it is cheaper. That's why I'm using it, my first preference. But now I have some critical traffic, right? First of all, internet is not secure. You are going to configure IPsec VPN for the security. But also guys, we are forwarding traffic through public network. Forget about the security, about the reliability, right? Your bandwidth will be changing of the WAN link, right? Internet is still today also, internet is not so stable, so reliable, right? But it is cheaper. That's why company prefer always and always IPsec VPN for connecting two sites. But let's say here I have one application and there is requirement of that application, right? Here are the user. These users are accessing this application. These all users are accessing this application. Guys, requirement of this application is delay should be less than 15 millisecond. Now you need a best transport, good transport here between these two sites. Then only remote side user can work on this application. Otherwise user from this side can work, but remote side cannot work, because through internet definitely there will be delay, more delay than 15 milliseconds, right? So what we can do guys, now we can use another transport, but for not all the traffic, because see, MPLS is costly, right? So I am going to purchase required bandwidth only, right? Whatever bandwidth is required for this application, for this critical application, only I am purchasing the MPLS connection, not for all the traffic. Still my general traffic and maximum traffic will go via IPsec only. IPsec is working, but some traffic now, critical traffic, should go via MPLS. This another service provider, that is MPLS. MPLS is not service provider, by the way, right? This is one kind of forwarding. Here we can say service provider. Technology you can say, through which I have created two sites. So now if I will talk about inside the MPLS, how MPLS routers are connected, because in the internet it's simple. In the internet guys, so many routers are connected together, right? And any protocol is running, multiple routing protocols are running, right? BGP is the main internet routing protocol, right? And all the public IP addresses are reachable, means all the routers have a route of public subnet. That's why all the public IP addresses are reachable. But what about the MPLS? So guys, if I will show you the MPLS network here. See what is going to do MPLS. See, for an example, now you can assume that this is your side. One side, okay? This is same lab 1. Now this is my one side. This is another side, side 2. Side 1 of customer A, side 2 of customer A, side 3 of customer A. There are 3 sides. And there is one another customer also, right? So service provider is going to provide connectivity to their customer. Guys, there are 2 types of provider, ISP and SP. What is the difference between ISP and SP? One is internet service provider and one is service provider only, who is providing the connectivity between 2 points, right? So for an example, this is company is my company and my site is in Delhi, India, right? Site 2 is in, let's say, US, or let's say in Bangalore, in the same country. For an example, this is my local service provider. If it is in different country, right, maybe here I can have different service provider, here we can have different service provider, and both the service provider will have some mutual redistribution. Both the service provider will have some mutual redistribution somewhere in the service provider network. The network is going to look like very large, right? There will be so many routers, because the same service provider is connecting multiple customers, right? So one side is in Delhi, one is Bangalore, one is in, let's say, Mumbai, right? All are connected through service provider network. Now what service provider will do? Service provider will create one VPN for you between guys, Delhi to Mumbai. Between Delhi to Mumbai, it will create one VPN for you. Here also it will create one VPN for you. And here also it can create one VPN for you, right? Whatever topology you want, whatever. Guys, if I am saying VPN, always keep in mind I am talking about overlay network. Overlay network. What is overlay network? It is virtual network, right? Which is running on top of the physical network, right? VPN is an overlay technology which works on top of the physical network. Physical network means underlay network. Like I have 2 router, as I told you, R1 connected to internet, INET, and R2. Right? Here I have public IP 1.1.1.1. Here I have public IP 2.2.2.1. So 1.1 and 2.2.2 are reachable with each other because both are public. How? With the help of any routing protocol, right? Internet routers are routing the traffic. This is physical network. This is underlay network. And the VPN which we are talking, to make communication between these 2 sides, between R1 and R2, what we can do here, we can create one virtual network where I will create on top of this physical network. With the help of this public and this public IP addresses, I will create one private network that is virtual, which is running on top of the physical. If physical network will goes down, definitely my virtual will goes down. But between router 1 to router 2, guys, there will be so many physical paths, right? So physical path is going to be never down. It will never goes down the entire path between R1 and R2. These are 2 sides. This is in India, this is in US, for an example, right? So in the internet, there are so many routers, so many paths are there, right? If you are going to search in the Google internet router, let's say, see guys, these all are what? Nodes. These all are nodes, your routers. See, to go from one point to another point, let's say from here to here, how many paths are there, guys? See, so many paths are there, right? So many paths are there, right? 2 point. This is internet. Between any 2 point, you can see multiple paths are there, right? So until and unless this public IP address will be reachable, my two public IP address will be reachable, my tunnel is going to be up, my virtual network is going to be up, it will be up. That is overlay, right? So service provider is also going to create here overlay network, right? Service provider provide you two types of link, L3 link and L2 link, right? L2 VPN and L3 VPN. Both types of VPN, will see the implementation of both types of VPN here. Even we have RR. We can delete it, RR. But if you want to make it more difficult, you can include it, right? So maybe customer is going to advertise your LAN prefix of side 1, you are advertising to service provider, right? Generally this router is called CE router, customer edge router, who is connecting customer network to provider, and this is P router, provider edge router, who is connecting provider network to customer network, and all the router inside the service provider is provider router. These are normal provider router, guys. If here I am going to connect, let's say, is this topology visible, guys, to you?
Yes, it is.
No, it's clear. Yes, what I am saying, for an example, here I am going to connect one customer. Here I am going to connect one customer A side 1, and this customer have another side over here, customer A side 2, customer A side 1, customer A side 2, right? So these two routers are PE router, PE and PE, provider is, and all the router between these two PE, like you can see from this path, from all the path, multiple paths are there, from all the paths, these all routers are called provider routers, right? So your provider router will be normal configuration router, but guys, P router is going to be high configuration router, because here you are going to, your service provider is going to create VPN for you, right? So what will happen in this scenario? We will advertise our route to P router of the service provider, and P router will advertise it to P router, right? They will do the routing inside their network. They will use MPLS technology for traffic forwarding, and through MPLS it will forward to another P router, right? Let's say this one, this P router, and again this P router will advertise the route to this customer, the side 3, and this way side 3 will learn side 1 prefix, first way, right? In this case you can see you are advertising your prefixes to service provider, guys. Service provider will have information about your network, private network. In this case, between C to P, you have to configure any routing protocol. C to P, let's say we are running OSPF. So through OSPF, I will advertise my LAN to provider is. And P to P, what it will do, service provider will create one MPLS L3 VPN. MPLS L3 VPN, right? And MPLS L3 VPN will convert your normal IPv4 prefix into VPN v4 prefix. We'll see the MP-BGP configuration. So between P to P over this VPN, we will configure MP-BGP to advertise the prefix, right? So this way P to other P prefixes are going through this VPN, and all the traffic will also go through this VPN. So service provider is mainly responsible to separate the different customer traffic. Again, this VPN is, guys, not secure. Encryption is not there, right? Service provider is responsible for separating the traffic, right? For each customer, it is going to create a unique VRF. We'll see that.
So I have a question.
Hmm.
So the CE routers is our own responsibility in the enterprise as a network engineer, right?
Right.
So the PE is for the people working in the service provider side. We don't have any business with that, except if we are in the
You
service
will have
provider.
call with the service provider for the configuration, like
Okay.
what OSPF, if you are running BGP, then what is your ES number, neighbor IP, right?
Okay.
Some policies and those all things. Definitely you need mutual
So we need to
understanding with your
communicate
service
to them.
provider. Yeah.
Okay. So the CE, is it the same thing as our core router, or is it the one that is connected to our core routers?
This one. This is the core
Yes.
router only, the same router.
Okay, core router. Okay.
Yes.
You know, in the industry, I think they normally give us, like our ISP, they normally give us a router.
This is this lab.
which-
This lab. This is the router R1. This one R1 here. This is the
Okay,
router
that's the
there.
one that the customer, the ISP will give to us.
Yeah, correct.
Okay, sir. Okay. So now from there we communicate with the ISP, so they will be the one managing their PE, and they give us the configuration of their OSPF and BGP AS number and
Correct. Like
everything to
here you are
confirm.
running what? OSPF. What I told
Yes.
you. Service provider is going to create one VPN. Our VPN they will run MP-BGP. So service provider will redistribute OSPF into BGP.
BGP.
Right.
Okay.
Again here on this PE router, here maybe we are running, let's say, EIGRP protocol. So service provider will redistribute BGP into EIGRP, and then customer will get it. Similarly, for this subnet, service provider will redistribute EIGRP into BGP, and over here BGP into OSPF, like that. This is how it is going to provide you the connectivity route. The another service is L2 service, right? They will configure something on their router, and after that these two interfaces going to, like, not these two interfaces going to like connect with each other. Like you can feel that now there is direct link like this. Service provider have just given you one link over here. You can configure one IP over here, let's say 10.1, here 10.2, and you can enable routing protocol OSPF to exchange the prefix. This is called L2 VPN. This is called L2 VPN. When we'll use it, we'll see that, right? When you need LAN extension, when you want to extend your sites at layer 2, when you want to extend the network through L3, we are connecting site through layer 3. We are dividing the network, guys. Layer 3 network subnet. We are dividing the subnet, right? In this case, we are not dividing the subnet, right? Here, let's say we have 192.168.10.1, here IP 10.1 and 10.2. Now through this MPLS link, we can also forward the L2 traffic. There is no involvement of service provider in traffic exchange. They have not created any VPN this time for their tunnel, right? They have just configured their interface, this interface and this interface. That's it. We'll see that. And after that, let me check, do I have any more left?
So what is that router that is connected to internet, Prabhu, in your old topology?
Which one?
The first topology that you shared, right? Like that there is
Okay,
one
I am
router
coming
that
on
is
that.
connected. Yep.
Okay, just give me 1 minute. Here you can see the clear understanding, guys. This is service provider network. This is P router. This is also P router. And router 1 only is connecting how many customer? 3 customer. Guys, customer will use private subnet, right? Let's say this customer using 10.1.1.1/24 here. Sorry, 10.1.1.0/24. This customer is also using same subnet, 10.1.1.0/24. Because private IP addresses are reusable. Multiple company can use same private subnet. This company is also using same subnet, right? Here OSPF is running, this company is running OSPF with service provider, this company is running EIGRP, this is running RIP or any other protocol, let's say BGP, and all are going to advertise their prefixes. Now this time my P router need to first separate the customer traffic. All the customer are advertising same subnet, right? But here we will have, guys, 3 different routing table. By default on the router we have single routing table, right? Router is going to install everything, all the routes in that routing table. But here on the P router, we will have multiple routing table, that is called routing instances, right? How we can divide the routing table of router? With the help of VRF, right? So I can create 3 VRF here, one VRF for customer A, one VRF for customer B, one VRF for customer C. I will put this interface which is connected to customer A into VRF A, the interface which is connected to customer 2 in VRF B, sorry, B to B, and the interface which is connected to customer again C or A if it is in same company, this is side of same company, same customer, then again this interface will be also in VRF A, right? So on router you will have 3 routing table, one global routing table, one for VRF 10, one for VRF 20, or maybe VRF 30 also. And here between P to P we'll see the configuration of VPN. P router will hop, this P router will advertise the prefixes to this P router, and after that I can redistribution over here. But here guys in the lab we are only going to configure service provider also and customer also. Okay.
So, sir, on the PE router for different customers, we're gonna need like large number of interfaces.
Why? Here I can use one switch and I can create sub interfaces here.
Okay.
If I have issue with port, I can connect one switch here. Right. So let me take you to the first lab. Someone has had question. Because, and we'll proceed from here as well, guys. We will proceed our class from here only. We'll start configuration from this lab. Here you are going to learn the OSPF routing protocol within the LAN inside the company. Right, all the devices are working. You can see I can turn on these devices. Yes.
Sir, in this diagram, can we connect server room to the distribution switches?
Yeah, of course. This can
So,
be.
so what is router R6 and R7 here?
Where is R6? R6, yeah. This one. You can connect internet directly here as well. Direct internet, right? Here, why I have added the router? Because I have different purpose. You know, like I don't want to involve this core layer in the VPN. Right, to connect remote side. For the backup here I have, by the way, MPLS. From this side we'll go to via MPLS, we'll forward all the traffic via MPLS, but I will have internet for backup. For backup,
so according to this scenario, R6 will be the customer edge, right?
R6, yes.
Yeah. Okay.
This can be also your customer edge, this can be also, right? I'm using this one. Right, guys, like inside the network I can have 2 router R1 and R2. Right, like this I can have single router also which is connected to internet. Here I can have 1 internet and 2 router. I can have then 2 router and 2 internet, right, for more availability. Here I don't have redundancy for service provider for internet. Here we have redundancy for ISP also. If ISP 1 bill goes down, then I have ISP 2. Or I can also have design like this: ISP 1, ISP 2, router 1, router 2. It is connected like this, and then I am again adding one more layer here, R3 and R4. Right? For the internal router here you will configure any IGP like OSPF. Right? So this is just a one sample.
Sir, when we should connect server room to the core or when to the distribution?
Why not? Why not means you can, brother. You can connect it.
In which case, in which case we should connect the server to the core router directly or server to the distribution? In which case you consider which connectivity?
That is the part of designing, right? That will depends on your requirement. There will be huge requirement, right? The list of requirements are there. It is not like you are going to collect the devices and you are going to connect to form the network, right? For the network, we will have the planning first, right? We are going to create blueprint according to the requirement. We are going to measure all types of traffic. That is network designing part. right? In the designing, you are going to learn these all things.
Okay.
Forget about this, that when we need to connect it
In
to
the
distribution layer, when we need to connect to core layer. Now you can
okay
connect
in
anywhere.
standard hello
Yeah.
in the standard configuration, should we connect the server room with core servers, or should
So
be connected to distribution?
see, it can be connected to core also, distribution also, or to access also. Doesn't matter. Anywhere. But here I have already some devices. Just I have replace it in another section. Anywhere you can connect it, right? Like this. Like this. Like this you can have network. Everything is connected to distribution layer only, all the department, right? Actually, if I will tell you guys the need of distribution layer switch. So let's suppose if you are implementing the network in a building, there is one building, and in that building we need to implement the network, right? There are some floors, let's say 10 floors are there in the building. At each floor we have different types of employees. At different floor we have different types of employees, means different types of department. First of all, to connect end users, I will use what? Access layer switches. I will connect all the end devices to access layer like this at each floor. I can have 2 access layer switch also, I can have 1 access layer switch also, depending on number of devices. Access layer, right? Now here you can directly use router, and you can connect this router to internet, no problem, that will also work. But what I told you, your router should be capable to handle all the traffic. It depends on total size of your network traffic, right? Now what I am saying, this is not a single building. Here this is building A, and like this there are 3 more buildings. First we need to connect those all buildings. Now guys, you need distribution layer. Here you are going to use 2 distribution layer, or maybe at least 1 distribution layer at each floor. If you don't want to use at each floor, no problem, but at least you should have 1 distribution layer switch at each building. Here I have D switch 1, and I am connecting all the access layer switch to this distribution layer. I can also have this distribution layer switch at each floor, or at least I should have 1 distribution layer switch at building, because we cannot connect 2 building through access switch. Otherwise guys, broadcast domain is going to be very large, right? If you are connecting 3 building through access layer only, right, the performance is going to be very bad. At least 1 distribution layer switch should be there at each building, right? Let's say here is my distribution layer, here distribution layer, and all the distribution layer will be connected together through guys optical fiber, through fiber cable, right? Because there are some difference between buildings, right? Or if you have 2 kilometer of distance, let's say this is your branch or DC, and after 2 kilometer you have a small shop or warehouse. So at each building you have placed 1 distribution layer switch, which is responsible for internal routing. By in this case you have only 1 distribution layer switch at each building. If any distribution layer switch will goes down, you will lose the connectivity of 1 building. Got it? You will lose the connectivity of
Yes, got
1
it.
building, right? So what is another option? If you need redundancy here, I can add 2 distribution layer switch at each building, and we can connect them. And now how you will connect all the distribution layer switch together? All the distribution layer switch to internet. You can connect direct to your distribution layer to internet as well, no problem at all. But what I told you here, this device have to perform WAN technology, which is Not possible. VPN, IPsec, advanced IPsec VPN configuration, right? Definitely not possible on switch. So here we will add one more layer. Which layer? Core layer. Somewhere I am going to add, install one rack. In that rack I will install some router, two router. And now I am going to call all the distribution layer here to router and the router to internet. Is it clear now? Why I am using devices like this here? But guys, all are possible, right? You can connect anywhere, that doesn't matter. What I told you,
I have
three
a question.
building can be also connected through access layer, no problem at all, but performance issue. Yes.
I have a question. The question is, if the distribution switches are responsible for routing and access switches are responsible for switching, what is the responsibility of core routers?
Distribution layer switch is responsible for inter VLAN routing. VLAN routing, not routing. Which routing? VLAN routing means LAN routing. You can say LAN routing, you can say VLAN routing, or you can say inter VLAN routing, not routing. You are wrong if you are saying layer 3 switch perform routing. That means you don't know the main function of layer 3 switch. Router perform routing, layer 3 switch perform LAN routing, one part of routing.
Okay, in a scenario where I have to connect a server farm, should I connect the server farm to the distribution switches?
Yes.
Or the core routers?
Here also you can connect. Here also you can connect. Right, guys, I can connect. Let's say I have some devices, some controllers are there. Let's say controllers. Let's say WLC. Right, ICE server is there, and we have some access point. Right, some other controllers, and we need to connect them. So we can connect these devices anywhere, even at access layer also, at distribution layer, at code layer. It depends now. See, for these controllers, do you need policy? Yes, I need policy. Which type of policy you need? Okay, this policy, let me think. Which layer is perfect? Core layer or distribution layer? Okay, distribution layer is going to be better because it will perform routing as well. It is going to behave like a gateway, and I am not going to configure any policy on router, right? Router is going to use the same configuration, the previous configuration, right? So anywhere you can connect, right?
Sir, can we use OSPF in L3 switches?
Yes, definitely. How you will perform the routing? Through OSPF, na? Only, na? So these are some lab which I have created. Later I will create more. Okay. And guys, should I need to discuss syllabus also? Syllabus. Let me tell you the syllabus randomly, right? I'm not saying this is all topics, right? Maybe I will forget many topics. Just I'm going to write the name of the topic which are in my mind right now. So first section is OSPF. In the OSPF, first of all, we are going to discuss the basic concept. Basic concept means their messages, neighborship, OSPF neighborship. There are two types of neighborship in OSPF. OSPF relationship with adjacency and without adjacency. OSPF neighborship with adjacency and without adjacency. So both types of neighborship. Then we'll see the area concept. Right? We have different types of router here, like ABR router, backbone router, internal router, ESBR router, right? So types of router, types of network, point to point network type, point to multi-point network type, broadcast network type, right? Then here we are talking about area ID. Here I am talking about standard area, type of standard area. It can be area 0, 1, 2, 3, any area. That is called a standard area. Apart from the standard area, we have some more types of area, like NSSA area, right? Stub area, totally stub area, and totally NSSA area. These are the basic concepts of OSPF, right? And while talking about this topic, we will have lab for each and every topic in the OSPF. Then guys, mainly we will focus on configuration of real-time scenario. Real-time scenario means we will try to cover multiple scenario like this, like our lab, where OSPF is required. I will try to teach you in the data center how your network design should be for the OSPF, right? Like if I will say, let's say this is my data center. This is my DC, and guys, my DC data center is connected to 5 different sites. 5 different sites are connected to my data center, right? Maybe one side is over here in Delhi, one side is over here in UK, one side over here is in Singapore, one side over here is, let's say, in the Ahmedabad, connecting, right? And in the DC, how we should design the network. See guys, I can place one router here, one router here, one router here, one router over here, and I can connect all the routers together. This can be one possibility, right? Another possibility can be here I can, sorry, here I can add one switch, right? And I can connect all the edge routers to this switch, and then we can enable OSPF. Now OSPF behavior in this scenario is going to be different, and OSPF in this scenario, if your routers are connected like this, is going to be different. Like OSPF network type is going to be different, right? Some operation is going to be different. Update exchange process is going to be different. Configuration is going to be different. So before talking about the difference in OSPF, we have to understand the difference between connecting these 4 sites in data center like this and this. Guys, you tell me, according to you, which is the better one? Connecting the router directly or placing one switch in between all the routers? Which option is best for my DC?
Placing a switch.
Placing a switch, yes. Because if I am going to connect all the router like this, first of all, let's say in future I am going to open one new site here, one new site over here. Now you can think about the connection, guys. Now see, it is going to be complicated, complex. It will make you confused, right? Lots of WAN link is added over here, and on all the link you are going to enable OSPF. There will be lots of OSPF flooding, right? So this network is not scalable. If I have connectivity like this, that is not scalable. But if I am using switch over here, it's very simple. I can connect this router on switch. Even on the switch, you will have more port than router, right? Even switch is cheaper than router. Here I cannot use switch because this is my WAN edge device. Edge device means which is connecting LAN and WAN. So edge device should be, guys, WAN technology capable device. Here we should have WAN technology capable device. Even if you are thinking, Praful, I will use firewall over here. Your firewall is not designed for routing, WAN routing and LAN routing, remember. So alone firewall is not going to solve your issue. Firewall is designed for security, right? So you should have router as well as firewall. If you have a small traffic, then only you can do same on firewall, routing as well as netting and VPN. But if you have huge traffic, if I will talk about the enterprise company, guys, which is the stable network, available network, there is SLA.
So in this diagram, which type of switch we should use? L2 or L3?
Any switch, L2 switch. Well, I will make the thing complex. I will use L2 switch here, right? So after that we'll see these kinds of design with their configuration, right? What will be the difference in configuration if you are connecting like this or this? And then, guys, at last we will have troubleshooting, right? While configuring only, I will be covering the troubleshooting part, but at the last I will show you all the troubleshooting commands of OSPF. If there is any issue, right, you will have multiple labs, right, minimum 5 to 7 lab in OSPF, and you have to configure, guys. If you are not going to configure, if anyone is going to escape the lab which I will configure in the class, then again I cannot promise you the improvement. Then I cannot say that 100% you are going to answer to the interviewer to the all question from this topic. If you are going to configure the lab with me, if you are going to ask me the question, if you have any doubt, then only you will be able to crack any interview.
So in this, thank you. In this topology for the data center, the DC, how is it possible to connect from, this one is in Delhi, one is in UK, all across the globe? How is it possible to now use the connection from different location to the switch on the data center? Is
Service providers are there, na?
We use a transport.
Yeah, service
Okay.
providers are there everywhere, right? Service
Because
providers.
I'm just looking at the cable that you just
No,
put
here we
into
have
the
VPN.
layer 2 switch. Okay.
Here we have VPN, right? Maybe IPsec VPN or MPLS VPN. If we have MPLS transport, then we'll have MPLS VPN. If we have internet, then we'll have IPsec VPN.
Okay.
VPN is always required whenever your two sides want to communicate through public network. Then VPN is required, right? VPN is the only technology which can make it possible communication between two private sites over public. Mainly in this course, we will be focusing in LAN routing, basic LAN routing, and main WAN technologies, right? Like MPLS is also forwarding, but in service provider network in the WAN side. BGP is also the WAN protocol. Okay, guys. So within 5 to 6 days, we'll cover OSPF configuration, and after that, we'll have 1 day for troubleshooting, right? After finishing all the topic OSPF, BGP, and VPN, we will have one complete lab where we need to implement everything together, right? Like here in my EVNG, I have shown you guys each section. First, I am going to teach you the each section, the OSPF section in lab 1, right? Maybe MPLS service provider configuration in lab 2, right? VPN in lab 3, right? BGP in lab 4, and at lab 5, I am going to combine everything together. How our enterprise look like finally. Done. This is my OSPF syllabus, right? Don't know I am forgetting many topic, but we'll cover those all topics as well, right? You can say OSPF from CCNA to CCIE, NA to IE, all the topics. LSA 1 to LSA 7. How many of you are confused with LSA, OSPF LSAs, guys? Tell me.
I'm not confused. I have seen your YouTube videos. Those are more than enough.
Okay, if you have already watched that. But if anyone is confused with LSA 1 to LSA 7, trust me. Just after 3 days.
My confusion is on 5, LSA 5 to 7.
Oh, okay. After 3 days.
It looked, yeah.
Again, I will ask you this question. Yeah, you can speak, brother.
Sir, as a core router, which router you are using, sir? Model, I think. Model.
Model. What I told you guys. This course is not everything. This course is not everything. Mainly here we are learning some part of the technology which we are using. The OSPF for internal routing, BGP for communication between the company, MPLS for service provider network, and VPN for two private side over public network. These are in use. These are industry use protocol, right? Which router you will use over here, that depends on throughput. Whenever we are purchasing a hardware, guys, for the company, how we are selecting the device? The most important thing is throughput. First of all, we are checking the throughput. I need 10 Gbps traffic, means it depends on your traffic. If you have 5 GB of traffic, you need 5Gbps router which support 5Gbps forwarding means it can process the 5 GB of traffic in 1 second. Means if here is the source, here is the destination at different side, this router should process the traffic within 1 second, this amount of traffic. That is the major part. And like this, there are various things in the designing we are learning, network designing, right? So you can like search these types of topic in Google, YouTube, you can watch the videos, you can read in the book which router will use here, right? Otherwise there are so many things. Is it possible to cover everything in guys 1 to 2 months? Not possible, no? Right? So it doesn't matter which router we are using. This is L3 device which perform routing, right? Just we are going to enable OSPF routing protocol here. So I need a device where I can configure the OSPF. That's it. Right? So selecting the device depends on various things. Your first of all your cost, before cost throughput, right? Multiple types of routers are there, even multiple vendors are there.
Okay, sir.
Guys,
Actually, sir, I am a regular subscriber of your channel more than 1 year. I came here to interact with you, sir.
Yeah, for this one is now for here at this place I can have more than 10,000 devices. More than 10,000 devices are there in the market which I can install here. Think. Right? So if you are in the IT, it's recommendation always you should update yourself. Right? At the same time you cannot learn everything. But first, definitely CCNA and CCNP is mandatory for everyone. All the network engineers should master CCNA plus CCNP first because that is foundation. That is compulsory. I always say to every network engineer that you should have mastery about CCNA and CCNP. If you have mastery in CCNA and CCNP, brother, at least you can decide the router at this place, which router I should use. Right? But in this course, we are not going to cover so vast syllabus. Right? Our syllabus is limited. This course is mainly designed for working professional who are not able to crack the interview, who feel that yes, I am stuck at certain level. Maybe someone is working as a NOC engineer, as he said, he is not able to change the job, not able to crack the interview. For that, after this course, you can go for CCNA, CCNP, you can learn, master it. Then again, you can take some time, you can revise it. After 6 months or 1 year, you can learn the SD-WAN, right? Or before SD-WAN, you can learn one firewall. You can master the firewall, then you can master the SD-WAN. Now you have CCNA, CCNP, you have firewall, you have SD-WAN. Almost you have understanding of 30 to 40% technology, right? Then if someone is interested in cloud, they can master the cloud computing. They can go for AWS, Azure. If anyone is interested in virtualization, they can make career. They can master the virtualization technologies. These are the common protocol used everywhere. This is for the people who have experience from 1 year to 10 years. That's it.
Okay, in order to configure GNS3, which routers and switches we should use?
In the GNS3, which router are there in your GNS3?
I don't have any. I have requested
if you have 2811, that is also fine. In packet tracer, 2811 is there. You can use that. In GNS3, if you are going to set up GNS through my video, you will get one router of 7200 series router. That is
MPLS enabled.
Much stable router for lab. Yes, not MPLS enable. You have to enable the MPLS, SAF enable. That is SAF enabled router, Cisco Express Forwarding.
Okay.
Right. Even all the routers, guys, here are SAP enabled. In the lab, all routers are SAP enabled. All the routers are forwarding traffic based on SAP table. But SAP is nothing but the duplicate copy of RIP. FIB is duplicate copy of RIP, right? So all the routers are going to build RIP through OSPF routing protocol, through any routing protocol, and after that, FIB, SAP will make one duplicate copy of that in SAP in FIB. And for the user data forwarding, it will use SAP table. Right? In the service provider router, we'll enable the MPLS manually. Yes.
Sir, can you help to set up the lab or?
I have already shared the video, na? Go through that video.
Okay.
That
So I
video
don't
will
have-
guide you to set up the lab. It's very simple, brother. Very simple. If you want to set up the EVNG, that is also simple because I have shared my EVNG OVF file. Just you need to import it in your VMware. That's it. All the router switches are already there. Router, switch, firewall, everything is already there in the EVNG.
Sir, is it available in your channel?
Yeah, it's available. I will share the link after the class also in the group,
Okay.
right?
Okay, it will be very thankful, sir.
So just download my EVNG OVF file and import it in your VMware, right? You will have the EVNG lab with all devices, whatever devices are required.
Okay, sir.
Right? Now, guys, if I will talk about the BGP, guys, just give me 1 minute, please.
That file can be imported in MacBook also?
Yes, I want to tell you one more thing, guys. That see, you all are working professional. Many of you are working, means more than 98% people are working professional, and you all are connected through me. See, you all are in WhatsApp group, correct? We all are connected. We all are like-minded people. We are working in the same industry. So guys, you
Correct.
can also talk to each other in group, right?
Right.
Don't know someone is working in US and someone is in India looking for job there, or maybe someone is looking for job in Bangalore and someone is working there in company. They can help each other, right, to clear your doubt. Whenever you have any question while performing the lab during this training, please share your doubt in the WhatsApp group so that other can also answer to your question. This way we can build a strong relationship with each other, and which will be helpful for us because we all are like-minded. Yes or no?
Sure. Right. Yes.
I am not going to delete the WhatsApp group after this training, right? Just I want to build a relationship for lifetime, guys.
Thank you.
I want you to connect it with me through WhatsApp, right? To share your thought every time, your success, your query, and every time I will be available in the group after the class also, right? Even my team members are there. If you are doing the lab in night, right, and if you have doubt, if you are going to put the query in the WhatsApp, we'll try to respond. If I am not available, the another trainer is also there who will try to reply your question. At the same time, I will request to all of you to share your answer, right? Share your question and share your answer in the group. We should utilize, you should utilize this opportunity. We all are connected together. This is not like social media, correct?
Correct.
WhatsApp group is our close community. We will only talk about our professional work there, about the issue in the network. Maybe someone has troubleshoot the IPsec today, right? It was difficult, but somehow it has fixed now. They can share his experience in the group, right? If you have any issue while troubleshooting something in the network, then also you can share your issue. This way we can improve our skill. It will also help me to improve my skill, guys. Okay?
Right.
So
Correct.
we will
Thank
be
you.
using our WhatsApp group as well, okay? And try to make the class bi-directional.
Sure.
Great.
Great. Okay. So
Yeah,
today we
understood.
have today we have not learned anything. Let me tell you about the BGP as well. First, guys, again in the BGP, first we have basic concept like the BGP reversible, IBGP, eBGP. Then some advanced concepts are there like the summarization, different types of route advertisement in BGP, self-advertised prefixes. Some attributes are there, right, for best path selection. In both protocol, in OSPF also we'll see the best path selection, and in BGP also will see the best path selection. We'll also see the path manipulation and load balancing in both types of routing protocol, and all are real-time scenarios, right? So through attributes we'll see the path manipulation, metric calculation, then load balancing. After that we'll see the policies of BGP, then redistribution, default information originate. These are the again similar topics like OSPF in BGP, right? So within 10 to 15 days we will be completing these two module, OSPF and BGP, with all the lab, all the troubleshooting scenario, session, everything will be cleared. 10 to 15, hardly 15 days, minimum 10 days. And after that, what we'll do, we'll connect one customer network, multiple sites through service provider. First we'll see the service provider configuration there, whatever concepts are there, and after that I will move to internet. Like we need to learn the transportation, two types of transportation, internet, how internet is going to work, and how MPLS is going to work, right? So both types of, we'll use both types of transport between the customer sites, and after that both together as well, right? At the same time, if we have both sides, how we will perform load balancing, how we'll configure primary and secondary scenario, those all things. This is about my syllabus. If you will say, Praful, just do one thing, at least teach us some basic thing from the OSPF, then no problem, guys. I can design one small lab. I can show you some basic configuration of OSPF today. Otherwise, today just we have
Yes,
talked about
please.
design. Yeah.
Thank you, sir. We have some other, like me, I have some other engagement. Can we stick to the time, like maybe 2 hours, 8 to 10 India time, please?
Yeah, we have 8 to 10 only, no?
Okay.
Class time is 8 p.m. to 10 p.m. 10 to 15 minutes can be vary up and down.
Okay, sir.
Right? But sometime regularly we'll have class from 8 to 10 only. Yes.
I have a question. You said you shouldn't do routing via the firewall.
No, no.
And you should have
I said you can
a
perform the routing on.
dedicated router.
I said you can perform the routing on firewall, but firewall is not designed for routing.
Mm-hmm.
Right?
How
You
would
should
you
use.
design a network if you want to put the firewall behind the routing? Would you just
Again, brother, what I am saying that here we'll not talk about network designing. How we are going to design the network.
Yeah.
Right? Here we are just configuring routing
Yeah.
for making reachability between multiple L3 devices.
Mm-hmm.
Right? These are
Yeah.
the design where we need to configure OSPF. Okay? Generally, you will have your WAN devices where you are going to configure the NAT, VPN, and the core routing, WAN routing will be behind your firewall. Right? But again, this is not sure.
Yeah.
My firewall
Thank you.
can be behind my router also, and it can be inside the LAN also. This is also fine. This is also one scenario, and here is my router, then internet, and then firewall, and then distribution switch. This is
Oh,
also
I see.
fine. Or
Yeah.
router, ISP, distribution layer switch, and here firewall. This is also fine. Doesn't matter. Anywhere you can add. Here also,
But
here
this
also.
way, even if the firewall goes down, the network should go down, right? From that side. Like if you put it behind the distribution layer, the whole network will go down since it's gonna have to go through the firewall, right?
Yes. So you can
Okay.
have 2 firewall.
Oh, I see. Yeah.
Right? And maybe someone don't need redundancy here, no problem, like me. See, I am teaching people, I have one firewall only here, and I have this setup. This is my
Mhm.
home setup. I have one Cisco router here which is connected to
Yeah.
internet.
To the network.
On the
Yeah.
Cisco router only, I have put it the Airtel optical fiber, which is the internet. I have point to point connection from Airtel office, because I am using a static IP address generally, because sometimes my student SD-WAN students access my server for the lab, right? So I need a
Yeah.
static IP address. I have 2 ISP connectivity from 2 ISP, one from Airtel and one from ISP Geo, because sometime during the class, ISP is going down here, internet is not much reliable. And then I have one ESA firewall here. ESA, old firewall, that is old firewall, but I am using it, right? But it will not goes down. I know that because the traffic is very less, limited traffic is there. And if the firewall or router or my switch will go down, no problem, I can wait for some time, I can fix it. That is my, like, 100% availability is not my priority. That's why I'm using this design now. Design depends
Praful,
on your
I
priority. What is your priority? Redundancy is your priority, cost is your priority, speed is your priority, performance is your priority. You might have heard about hub and spoke and full mesh. Hub and spoke and full mesh. Both are, guys, WAN technology overlay. Full mesh. Both are VPN, virtual private network. If I have 4 sites in the company, I can connect all the sites together also, means I can create so many VPN here. That is full mesh. Or I can have hub and spoke, means one router is hub router and all other are spoke. Now if you will say that why here we have not added the link, why I have not used the firewall, there is no sense.
Praful, can I interrupt you for one moment?
1 minute, brother. 1 minute. So, like, you can see both the design is fine, but it depends on company, right? Some companies using hub and spoke, some companies using full mesh. If your priority is high availability, you will go with full mesh topology. If cost is not your priority, because it is going to be costly, right? You need lots of engineer. If you have so many sites, let's say 500 sites are there in the Google has 500 data centers across the globe, and their all data centers are connected to each other, right? Managing their network is difficult. So many teams are required. Other hand, another company is going to say, no, boss, high availability is not my priority. Sometime I can manage the dawn, but it should be cost effective. That company will go with hub and spoke. Getting my point? So the design depends on my requirement.
Yeah. Thank you so much. Yeah. Sorry, I disconnected for, like, my phone died, so I had to go to the laptop.
Yeah, okay.
Yeah,
You
thank you.
can. We are about
Thank
to
you so
finish
much.
only.
I am really interested with this course. It looks really good. Thank you.
Great. Thank you so much, brother. Yes.
Can I ask you a question, Praful?
Yeah, go ahead.
Yeah, I'm in the designing of railways and metros designing, and most of the time the customer asks me, what is the standard practice? So when they ask me standard practice, then I cannot tell them that it depends upon your requirement. So the Cisco requires that you 3-tier the core, distribution, and access design. And what is the standard design? So as per the standard design, what is your view? We need to accomplish that also.
Switch.
Right. The guy asked you a question: if the WAN network should terminate on a firewall or it should terminate on the right router. So what is the standard practice advised by Cisco? If it
So
is router,
same thing
then
what I am
it's
saying,
okay.
that you have to learn it by yourself. From the Google,
I
YouTube, you can
addressed
go
it.
with book.
Yes, I got it. Okay. I am already designing networks. I'm already terminating it on the firewall. But what is the standard practice?
Same thing I am saying now, that here we are not going to learn the network designing.
Okay.
For me, the extended network can be here. I have one access layer switch. Some end users are there. This access layer switch is connected to one router. Router is connected to internet.
Okay.
This is a standard design according to me, right? But
Okay.
here you should not ask question about the design. Like if you are working in designing, let's say someone is working in telecom, so if he is going to ask question from the telecom sector, right, then how we can cover the our syllabus like the OSPF, BGP, MP-BGP and the VPN, MPLS. These are
No,
the most
no,
commonly used protocol, and this
I
course is going to cover these protocols, these technologies.
I got you, but the motive for me to join this course is to ask a question for MPLS and OSPF which suits my requirement also.
Okay.
I appreciate what you are going to tell me, what you're going to teach me. I appreciate fully, but I may ask, if you allow me, the question which I need to ask you for my current deployment. If you allow me, that's on your
No,
wish.
I already told you that whoever have the scenario, the real-time scenario where you are working, you should create the lab, you should share with me. Definitely we'll go with your scenario. I already told you that. But
Okay,
here you
that's
are
enough for me.
asking the
Thank you.
question from firewall is behind or after the firewall, before the firewall, here or there. Like that is, we are going like away from the syllabus, away from our technologies, right? If you have the setup
No,
and
even
there
if
OSPF, BGP, MPLS, these things are required, then it's a recommendation to you to design your setup in your EVNG lab. Okay,
yeah, I
design
got it.
the same setup in your lab, and tomorrow when we'll start the class, first share your screen, show me the topology, and definitely I will consider that in my OSPF teaching.
Thank you very much.
I will
That's
show
what
you
I'm
the
listening to.
OSPF configuration there in your topology.
Thank you. Thank you. Thank you.
And not only your, right? I am expecting that multiple people are going to share their topology,
Yes.
their company topology.
Yes. That is how we all gonna benefit with each other's knowledge.
Yes, exactly.
Yeah.
Right. So
Good.
see,
Good.
I have designed the lab according to me, right? These are the simple lab I have created it, but I don't know about your scenario, and it's recommendation, guys, that you should join, you should design your scenario in the EVNG on earliest as soon as possible, because we are going to start OSPF from the zero, from the basic, right? So I will be taking example in your scenario also, right? It will be helpful for me also to give you more example. It is going to be helpful for you all as well, right? You are learning the real time scenario. I want to try, I am trying to cover as much as example is possible, right? If you cannot design the lab in EVNG, you can do one thing. You can design your network in on the paper. You can drag the topology, you can connect it, right? And you can mention the protocol, which protocol is running there, right? And after that I will show you how OSPF is going to work there. If there is any issue related to OSPF, how you are going to fix it, how you will increase the network, decrease the network, what will happen when link will flap, redundancy, load balancing, everything in your case on your topology. Okay,
Got it, Praful. Thank you very much.
and forget about the firewall and those all things. Where is firewall, where is WLC, where is those are like we can connect anywhere. Firewall can be connected anywhere in the network, and firewall can also behave like a layer 3 device. If I am using firewall as a layer 3 device, then OSPF is going to work there exactly same like router, right? Doesn't, for the OSPF, guys, doesn't matter here is my router is connected to internet or firewall is connected to internet. OSPF is an open standard protocol. OSPF is going to work exactly same here also, here also. Yes, na?
Yes, right.
Instead of having two router, I can also have one router and one firewall at one side. Right? And if you are, focusing more on design over here at this point at core layer, then I must tell you guys, nowadays, we have SD-WAN, right? So at WAN edge devices, we have VAs or CAs. We have VAs and CAs. Firewall is not required then. If you want to put the firewall, you can put, but your WAN edge device, which is CAs or VAs, will only configure the VPN, will only establish the VPN. Again, everything is going to work same, right? Doesn't matter this is router or firewall or VAs or CAs. If it is my WAN edge device, which is connecting LAN and WAN, OSPF or any routing protocol, VPN is going to work exactly same. Right? So in the production, if you will ask me, give me the today's world example, like today's what devices we are using at WAN, right? Someone had asked about the firewall, someone had asked about the router model. So guys, nowadays we are using SD-WAN devices, right? Many companies are moving from legacy to SD-WAN, right? And some companies, many companies are still using the traditional WAN. But
Praful, the SD-WAN, the deployment of SD-WAN, I believe, is less than 5%.
Yes, less than 5%.
Even if in government tenders, yes.
But we are moving, na brother. Continue. After 10 years, this percentage is going to be high. We are moving towards SD-WAN. Through SD-WAN, it's easy. Only small organizations will be using legacy WAN, traditional WAN.
Yeah, we're already actually introducing SD-WAN at our company. We're already learning about SD-WAN. We haven't set it up, but we are going.
Yeah, many companies have the hybrid setup, right? Some parties, even in my company, some parties based on SD-WAN, which is managed by the controller, and I am only managing the CS and VS as well in my company through the vManage, through the controller. Right? Guys, the reason of SD-WAN, see here I have router. This router is my WAN edge router. And nowadays what happened? We are placing our services, our application on the cloud. Am I right? Nowadays, we are running our application on the cloud, and cloud is reachable from internet, right? So earlier, application was here inside my network and the user were accessing it. That was fine. Now the application is on cloud, right? User will access it through internet. Internet is public, not secure. So I need what here? Firewall. 110% you need firewall if you have some company application on the cloud. Without firewall, you can not set up the network. You cannot compromise with security here if you have something on cloud. And most of the companies are running their software on the cloud. So that's why we come up with SD-WAN, right? SD-WAN allow you to access your cloud service without having firewall here. But again, in the SD-WAN also it is going to form IPsec with other side. Means it is going to create the VPN and the routing protocol will work there. Exactly same. Everything, my routing protocol like OSPF, BGP or MPLS, MP-BGP, these are going to work exactly same in SD-WAN also. Right? So before SD-WAN, we try to solve this issue. Like what we did, we started uses centralized firewall, right? Let's say here I have one DC, data center. And in my data center, there is one firewall. And this is side one. And I have application on cloud. So if user want to access the application which is running on cloud, first user will reach to data center. In data center, I have firewall. That firewall will inspect the traffic, whether it is allowed to go or not, whether it is allowed to access this application or not. If it is allowed, then from DC, I am going to forward it to cloud, and again reply will come in this way. But here, user started getting latency, right? Because to access my application, my company application, first I am reaching to data center and then cloud. Earlier, when cloud was not popular, at that time, all the application was in data center only, guys, right? So if user want to access the application, they will reach to data center. That's why. But issue came when we come up with cloud, right? That's why SD-WAN is in use nowadays. This is why companies are moving towards SD-WAN, right? Doesn't matter which device you have at WAN edge. It can be router, it can be firewall, it can be SD-WAN WAN edge. My VPN routing protocol is going to work exactly same. Okay, and again, what device you should use in the company, that is not our concern for now, at least for this course, during this course. If we have any L3 device, WAN edge device, how we'll configure that, that is our concern. How the technology is going to work there. Okay, now guys, tell me how was the class, and please ask me the question.
Can I get a video for SVIs? Do you have any pre-recorded video?
Yes, sure. Whatever videos are required, just let us know in the WhatsApp group. We'll provide you the link there in the group only. What I told you,
Thank you.
we are going to talk in WhatsApp group 24/7. We can talk there. If you need anything, you can just let me know. I will share the link. I will provide you the best video to learn SVI. And this is good that you are asking. Guys, if anyone is there who is thinking that any topic before OSPF is not clear to you, ask me for the recording. I'm going to send you the recording. I am expecting that you know before the OSPF, at least you know the routing, how router is forwarding the traffic, RIB based forwarding and FIB based forwarding, the load balancing on the router, the by default load balancing, right? Per destination load balancing, per packet load balancing. Those are traffic forwarding behavior of L3 device. So if you need video for any other topic, you can let me know. But from tomorrow, I am starting the OSPF. Now we don't have time to cover the basic of OSPF, so better to start from tomorrow. What do you guys say?
We will be starting from Monday, right?
Yeah, Monday, exactly.
Okay.
Sound good. Sounds good, teacher, trainer. Thank you.
Right? Any suggestion for my teaching or something? I should go slow, I should go fast.
You know, I think your teaching is perfect, and I love that the way you are doing, starting from the scratch, so we could have better understanding how these things work, and which I love it.
Great, thank you so much. Okay, if anyone have any suggestion, guys, feedback, please share. You can also share it in the WhatsApp group, and definitely I will try to implement it in my teaching.
Praful, you're good, you're very good. Our own topology with you.
Your voice is only for me or for everyone?
Only for me or for everyone? How to share
I think it's everyone.
my topology
I think
with
it's
you.
everyone.
Hello?
No?
Hello?
Yeah, it is for everyone.
Now it's clear.
Yeah, now you can speak, brother. Your voice was not clear earlier.
I just wanted to ask you for
Still
topology
same.
with you.
Same.
Gopal, it's the same issue.
No issues. I will put my in WhatsApp.
Yeah, you can. WhatsApp. See, there is issue with voice. I think from his side. Gopal, please put yourself on mute. You can put your message on WhatsApp group. In the WhatsApp group, definitely I will check. Yes.
Thank you.
You're most welcome. Yes, Vanu.
See, the reason most of them joined might be here because your content is available on YouTube most of the time, right? Most of the scenarios you have already covered. I think few people like I am also one of them. Maybe wanted to share our existing setup and wanted to get go through or have some query. That's where I think a couple of them asked on the out of the syllabus of this course. But maybe if you are, I mean, if you like take them after the class, maybe you can just tell them that either we can take it one last day or one
you
day
know
we can have for the doubt
what
session like that.
what I want. You know what I want? I want that you should understand the OSPF, BGP, MP-BGP, MPLS, and VPN in your company network. Only these protocol in your company network. Forget about rest all thing. That I want.
Got it.
Share your topology to cover these parts there. And you know these are the most important part of your network, right? After this course, if you will have any other question in your scenario, you can ask me that separately. First, let's cover these protocols in the everyone company's setup, right? So that's why I'm requesting you to design your setup in the EVNG. If it is not possible in the EVNG, then you can draw it on the paper and you can send me the photo. I will design that in EVNG, or I will ask to my team to design it. Your setup, exact setup.
Yes, got that. Yeah, we will use WhatsApp forum to exchange all setups.
Yes, exactly. Yes, guys, anything else? Anybody else?
Can you share the WhatsApp link in chat?
WhatsApp link? You don't have access
No,
to
I don't
WhatsApp group?
have. No, I don't have.
Then how did you got the link of this
My
class?
my brother has joined. He registered for me. Okay, I will ask my.
So you can ask for the same on WhatsApp. Okay,
Okay.
just message
Yeah.
on the WhatsApp, right? Arun is there, who is responsible for these all thing, adding and removing the people from the group. He will take care
All
of
right.
this.
Yeah. Yeah. Okay. Thank you.
Yes. Yes, guys.
Yeah, one question. If you already covered in any other earlier sessions, in YouTube, see, our setup is like, maybe it's out of the context of this course. So we have core, core switch and DMZ switch, and in both L3, all the SVAs are in the core, respective core and DMZ. Then we are running many VRFs. All these VRFs using transit, then we have different firewalls before the WAN router.
Okay.
So that's what I wanted to cover. That maybe I'll try to design that, and we'll see in the
Yeah,
maybe
that
next
will be
coming.
covered here, brother. Right? Please design the topology and put it in WhatsApp group. Okay.
I mean,
Yeah.
we're still technically using static routes because we work in schools. It's a small company, so yeah, we still haven't gone to OSPF, for example. Do you still want me to share static routes that way?
What, brother?
Like, do you want me to create the diagram with static routes for now?
No, I want you to design your company network. See, if you are working in your company and you thought that OSPF is running there, BGP is running there, or MPLS, VPN, VRF, if these protocols are running there, so you need to design that topology and just mention it that it is running over here. And it's my responsibility to cover it, right? I will show you in the class that how it is working there. If there will be any issue, then how you will be troubleshooting it.
Okay, thank you.
Right? I need your company topology, the blueprint
Yep.
of your company network. Yes, Mohammed.
Sir, I have a doubt. We configured in between LAN and WAN a default route and NAT. What is different? What will happen in network?
Like
We configure
default route will route
LAN.
all the traffic towards internet, and NAT will change the
Okay.
source address. Source address is going to be private.
Okay. But
See,
when we configured after configuration of WAN NAT only, we can communicate in other network through
No,
ISP, right?
LAN NAT is used to make communication between private and public. Let's say this is ISP,
Okay.
and on the ISP there is one server 8.8.8.8, and here I have one
Okay.
user whose IP address is 10.1.1.1 who want to access internet. So my user is going to generate traffic. Source IP will be 10.1.1.1, destination IP will be 8.8.8, and it will forward traffic to their gateway, means to router number 1. Now router 1 needs route now to forward the traffic to 8.8.8. How router will get route? So that's why we will configure one static route here, right? The subnet which is running over here on the WAN link is public subnet. Let's see here IP address is 1.1.1. Here IP address is 1.1.1.2, right? So when user will generate the traffic, source IP 10.1.1.1, destination IP 8.8.8, it will forward to router. Router don't have route. Router will discard the traffic. So that's why here I will configure one default route towards internet. Why default route? Because see, you can configure the static route for 8.8.8 also, but guys, like 8.8.8, million of subnets are there, million of servers are there on the internet. We cannot configure route for all the public subnet. So that's why here I have configured one default route. That is fine. Now what will happen when user will generate traffic? User will forward traffic to router 1. Router will compare destination IP address with routing table, which is 8.8.8. It will match in this default route. It will forward the traffic to internet. Now internet will check destination, internet router. It will check the destination IP. Destination IP is 8.8.8. It will send the traffic to the server. Now server will generate reply. In the reply, source IP will be 8.8.8.8 and destination IP will be what? 10.1.1.1. Yes, na? Then again server will forward traffic to router. This router is going to compare destination IP with routing table, but there will be no any route. This is private network, right?
Yes.
ISP will never install the private network in their routing table. So there is no route. ISP router is going to discard the reply packet. That's why here I have enabled the NAT. So when I will enable
that
the
time
NAT,
the communication is not possible, right?
yes, not possible. When we'll configure the NAT, what will happen? Router 1 will change the source from 10.1.1.1 to 1.1.1.1, right? This IP address.
Okay.
And then it will forward to ISP. This time server will generate reply for 1.1.1.1. Source 8.8.8, destination 1.1.1.
And then 1.1 translate to
again router will
private
perform
IP.
translation from public to private. Yes.
I thought default route also it will work communication.
No.
Okay, doubt is clear.
Anything else?
In our topology, one ACS is access control. What is that?
ACS is similar like the ICE server. I have closed the lab. Tomorrow I will show you.
Yes. No need to open. I just
ACS means
I
access
don't know. I know.
control server. It is used to control the access, right? Let's say I have a router and I have enabled that.
ICE, right?
Yes, exactly.
Okay.
Telnet and SSH is running here, right? So I can get the user who can access my router. Through ACS server also we can control the user. Similar like ICE.
Okay.
Cisco ICE.
This any difference? What difference in ICE and ACS?
ICE
Because
is the latest technology.
vendor,
There are so many advantages of ICE.
yes, I know. We are using ICE, but other is Cisco product.
ICE is Cisco product.
Okay. Then ACS also same vendor or another vendor?
ACS is the name of server, right? ACS means access control server. It will use the protocol like AAA, route or TACAC. TACAC plus.
TACAC and the radius also.
Yes.
Okay. Same as ICE, right?
Yes, exactly.
Okay, thank you.
Yes, guys.
Okay, thank you.
Bhuneshwar, Dhoni, Ali. Do you guys have something? Fazuli.
How you share this one link for this video?
You will get it on WhatsApp.
Class?
Wait, you will get it on WhatsApp.
Okay.
Yeah. Karthik. 2 Karthik are there. टू कार्तिक कर दिया लोगो guys, first of all I will request you everyone to come with your genuine name in the next class, okay? So that what I told you, I want to build a relationship, I want to be connected with you through WhatsApp. So please join with your correct name. I remember my all the old students, right? But when someone is using the ABC or the internet user like that type of name, it's difficult to recognize. So please join with your right name from tomorrow. That is just a request. Anything else, guys? Anyone?
When you say tomorrow, you're talking about
No,
Monday,
your
right?
voice is not.
No,
Your voice,
your
yeah.
voice,
When I am
yeah.
saying,
When I am saying
put yourself on mute first. When I am saying tomorrow, means
tomorrow
Monday.
means Monday. Got it. Thank you.
And please change your mic setting. There is some issue.
I will.
Yeah. Okay, guys. Then that's all for today. Thank you.